Okay, so let's continue our lecture today. So, okay, so okay, so I think I left out the place where I want to show that this gamma restricted on this ui alpha. Yeah, so yeah, so remember we have this we have this ui lambda, right? So we have this okay, so what you show so we have the gamma restricted on this ui lambda from ui lambda to ui, right? Yeah, so from ui lambda to ui is a wait, let me double check. Okay. Okay, so okay, so basically we want to employ the holomorphic inverse function theorem, right? Okay, so basically okay, so basically to show that this gamma restricted on this ui lambda to this from this ui lambda to this ui is a biholomorphism. So basically the idea is that we can okay, so basically wait, how did we show that? How we show is okay, so let me check. So so to show that it's a biholomorphism, okay, so we want to show that it has a holomorphic inverse, right? So okay, so namely, okay, so we want to show that it has a holomorphic inverse. So so I think the idea is that wait okay, we know that this gamma is let me think. Okay, so it is a bijective, of course, and then it's holomorphic.
Yes, so we need to show it at holomorphic inverse. So we want to apply the holomorphic inverse function theorem. So let's see. Okay.
Okay, so in all this, okay. Okay, so what we know is that, wait, if I compose this one with, okay, so we know that this gamma is a local biholomorphism, right? Oh, okay. Wait. UI biholomorphism on this UI. Oh, okay. Okay, I think this gamma we have and then biholomorphism on this UI lambda. Okay, so we know that this gamma locally is a biholomorphism, right? Okay, so then how do we show that it's a biholomorphism on this U alpha? Wait, locally, locally, let me see. Oh, sorry, I just like laughing at myself. Yeah, so, so locally is a biholomorphism. So why does it imply that this one is a biholomorphism? Okay, so wait. Okay. Okay, so I think we can use the okay, I think we can use the idea that wait. Oh, it's a biholomorphism. Holomorphic inverse. Okay, I think. Okay, so we know that this gamma is a local holomorphism, right? So local holomorphism means that for any. Okay, so basically, let me check.
for any open, so for any point there is a open let me see, for any point there is a, okay. So this implies that so let's say like so we pick a point P, okay. So we pick a point P in this UI lambda. So then this implies that there exists a UP containing this P, and then such that this gamma retrieved on this UP is holomorphic. Okay, so now what you have is that so you know that this so on this UP intersect, wait, why am I confused? Okay, so on this UP, so then so then you have that this, okay, so then you have that this gamma maps this wait, the gamma restriction UP is holomorphic. Let me think. So I want to say that this gamma so well, I want to say that this gamma intersect this UP. Gamma on this, this gamma from this, this gamma from this UP intersect this UI lambda is holomorphic, right? But okay, because if you take any holomorphic, so okay, so I want to show that. Okay, so I want to show. So this gamma restricted on this UP intersect this UI lambda is holomorphic. Okay, so how do I show that? So, so of course it's a bijection, right? Yes, and then secondly is the y is a holomorphic. So okay, so because for any okay, so UP intersect UI. So so here you have this UI lambda, and then pick a point P, and then this is like the UP. Okay. I think this is, wait. So, okay, so first I want to show that this is holomorphic, right?
so Y is holomorphic. So if you take any cover. Okay, so wait. So you take any wait, how do you show it's a holomorphic? So you take any so what do you take? You take any wait, how do you show this holomorphic? So you take any inverse, right? Wait, let me think. So yeah. So okay. So basically you take any okay, you take any chart, right? So you take any chart and then what you do is that so after you take the chart. Okay. So basically you show that let me think. You show what? Okay, so here you have the image as so here you have this image as this UI lambda mapped to is UI, right? And then UP, let's say that is mapped to yeah, mapped to UP to that, okay? Okay, so okay. So I want to show that this okay. Okay, so this holomorphic is the same thing as if you take any so okay. So basically if you take any okay, so basically if you take any chart here, right? So let's say that you have a chart phi I. That's maps UI to UI prime, okay? And then we're gonna say what? So okay, so you want to say that wait. Okay, so let's say that you have this phi I restricted on this UI intersect U to the P. Okay, yes, because it's yeah, okay. Oh, sorry. Yeah, local biholomorphism. Yeah, biholomorphic. You can say that it is relatively to the holomorphic structure. Okay. So the holomorphic structure. Okay. Yeah, or holomorphic structure. Let's say you can say this atlas A tutor. Okay. This is like a holomorphic structure. Okay, so yes, okay. So now what you have is that you know that this okay, so this is a chart, right? So this phi is a chart on this set. On this, yeah, you can view the set as a complex one manifold with these local trivializations, and then yes, okay. So now, what do you want to show? Okay, I want to show that this is holomorphic, right? So let me think. Okay, so let me think. So why? Okay. Okay, so holomorphic means what? Holomorphic means that if you take any, yeah, so if you take any chart, right? Okay, so wait. So this is the equivalent of saying that this, okay, this phi I, okay, let's call this okay, so let's call wait. So this phi I composed with, let's use this phi I because they are the same thing. Okay, phi I composed with this gamma restricted on UP intersect UI lambda. Okay, is holomorphic on, yeah, it's a holomorphic function on this set. Yeah, so UP intersect UI lambda, right? Okay. Okay, so namely, this is the same thing as so what does this mean? So this means that so this means what? This means that if you take any local chart, right? Okay, so why is it true? So if you take the chart, okay, so if you take any local chart, that's okay. So say you take any chart, let's say u phi u prime, let's say, or u tilde, okay, in this A, yeah, okay, in this atlas, and then what you do is that, okay, so you want to show that, okay, so what you show, so what you show what? Okay. Okay, we want to show that if you take any want to show what? Want to show that if you, okay, so okay, So we want to show that phi okay, so I think what's going on is that you have this phi inverse of yes wait let me okay, so I think this is like phi okay. 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 So all this phi inverse from this phi inverse of okay this okay so this so let's call this this UP intersect UI lambda intersect, so this is the region, intersect the U to what? Yeah. So okay, so phi compose gamma retreat on this UP intersect UI lambda composes. Okay. Okay, let's see from here we see, okay, it's holomorphic. Okay, so why is holomorphic? Okay, so we know that gamma retreat on this UP is biholomorphic, right? So it's a holomorphism. So this means that this means what? This means that for any okay, so gamma, okay, so this implies for any this implies what? What do you mean by okay? gamma reflected on UP is holomorphic, implies that we have this let me think. Gamma reflected on UP is holomorphic implies what? Okay, so if you take any chart, right? Okay, so we want to show, okay, yeah, we want to show that this is the holomorphic. So okay, we want to show that this is holomorphic. So basically, okay. Oh, because this is a chart, right? So this is a chart. So this holomorphic means that wait. So this is holomorphic means so this is holomorphic means if you take any okay, so if you map this okay, so okay, so this gamma let's say that it's from like UP to yeah, okay, and then you take the so you take any yeah, you take any you take any holomorphic, yeah, you take any chart on this X. Okay, so let's say that you take any chart let's say yeah, I think it's the same way. So you take, so do that, take any chart, let's say phi so I use letter U, so maybe I use letter V here. Oh. Okay. So yeah, so this belongs to, let's say that this is like a atlas in yeah, in this alpha, okay. And then okay, so then this implies what? This implies that you have this phi composed with this gamma restricted on this, okay, UP, okay, is in, okay, so yeah, so this is true for any phi, right? So this is, yeah, this is true for any phi. So it's in this yeah, it's in this O of UP, right? Yes. Okay. So now what do you want to show? Okay. So we know that this is true. Okay. So for any, okay. So for any, right? Okay. Okay, so here, what you do is that, okay, so you take this, oh, okay, so what do you want to show now? So, okay, so okay, so we take phi 2b is phi I, right? So then we know that this wait, what? Okay. Wait, I was a little bit confused. So, okay, so a continuous mapping from x to y is holomorphic is a function. Okay, okay, so a continuous mapping from if phi composed with I is in a continuous mapping of phi of x to y is holomorphic if okay phi wait okay let me think. Oh, okay. Oh, okay. Okay. I know where I get stuck. Okay. Okay. So, my bad. Okay, so okay, so this should really be phi inverse u, right? So yes, so yeah, so here okay, so here let me see. Yeah, so here basically the idea is that yeah, so this is like the setup we're interested in, right? Where is the chart? The chart is exactly on this one. Yeah, which is exactly the same thing. So we take the inverse, we get the same thing, okay? But here, the thing is that, so here, we don't really get the same thing if we take the, yeah, because this one, the image, they have the overlap. So if we take the inverse, then we don't get the same thing. Yeah, so that's why yeah. Okay, so, so here, what should really going on is that, okay, so if you take any, if you want to take this phi I, okay, so if you take any of these phi, right? So what should be here is that it should be O of gamma restricted on this P inverse of this V, right? Okay, so here, if I take this to be phi I, then if I take this to be phi I, then it should be just okay. It will be just okay. So it will be this O of wait, why am I confused? So yeah, so it will be O of what? It will be O of okay, it should be wait. Wait. Sorry, let me hear again. Okay. Okay, so if I so here so this is a holomorphic map, right? So okay, so this is like X, this is like the Y, and then what you do is that you and then you have the chart on Y. Okay, this phi, strictly speaking, is not a okay. Phi restricted on this set is a chart on Y. Okay, so basically what you do is that you take the okay. So what you do is that you take this okay, yeah. So you take this U tilde, UP tilde. Okay, so this is by strictly speaking, this one should also be, yeah. So strictly speaking, this phi should also be like V intersect UP. Okay. Yeah. So V intersect this. Yeah. Okay. Okay. Good. Okay. So yeah, because this phi is okay, because this inverse is exactly this step, right? UP intersect the UI. So therefore, okay. Okay, yeah. So therefore, yeah. By definition, this is equal to okay. UP intersect this UI lambda. Yeah, okay. So yeah. Wait. Okay, so why? Let me take any. Okay, you take any x. Okay. Give off. Okay. Give off x. Okay, I'll yeah, I think this is true. Okay, so I'll okay okay. Let me verify this. Let me verify this. So. Okay, so let me make myself comfortable. Sorry. Okay, so if you take any x, right? So you know that this gamma restrict on this UP of x is in this set, and then this